In this video, we'll connect the peak probe to our HV to LV DC-DC converter, establish CAN communication, and configure the first settings. You'll also get an overview of the different capabilities and features right at your fingertips. Let's get started. For this tutorial, we'll use our DCDC MP with dual LV ports in the liquid-cooled configuration. However, the same steps apply to all our HV to LV models, including all our SP and LP models. Before you start your first power conversion, the converter needs to be configured. First, use a peak probe to link the converter via the signal connector to your computer. On our HV to LV models, the power supply is ensured by the LV side. When connecting the product for the first time, we recommend using a supply voltage below 20 volts. This helps prevent any damage to the converter. Use this diagram as a guide to connect the peak probe to the converter. Once everything is properly connected, launch the CAN loader application on your computer. By default, the product bit rate is set at 1 megabit and the address range at 0x780. The CAN loader, along with the DBC file and the CAN dictionary, are available on the USB drive provided with the unit or on our online portal. On the Loader tab, once the CAN loader has detected your peak probe, you will see the green message, Peak Probe Operating, at the bottom left. Then, turn on the power supply for the converter. The CAN loader will automatically detect the product and communication can begin. On the main tab, you can now see information related to your product, including its configuration and the software version currently installed. To configure your product, go to the Settings tab. Here you can adjust basic settings such as the overvoltage protection threshold, the voltage range, and the current limit on each side of the converter. Let's first configure the two ports on the LV side. First, set the overvoltage threshold. This enables the other settings in sequence. The OVP threshold is the value at which the converter will trigger an error if the measured voltage goes higher. Then set the Vmax value. Vmax is the maximum voltage allowed in the setpoint message range. If the setpoint value is higher than Vmax, the converter will reject it and output the Vmax value. Vdefault is the initial value set at the beginning of the conversion if you don't send a new setpoint value to the converter. The Vmin is the minimum voltage allowed in the setpoint message range. If the setpoint value is lower than Vmin, the converter will reject it and output the Vmin value. So Vmax and Vmin define the acceptable range of values for the setpoint message. If the output voltage drops below the overload threshold value, the converter will increment the overload count message. This value helps you determine whether your output current limit is too low or if your loads are demanding more current than expected. I limit is the default current limit the converter will accept if you don't send a new one. The line resistance is used as an offset value to compensate for voltage drops caused by long cables. If a LV port is connected to a battery, tick the box. Repeat the process for the other LV ports if available. Now let's move to the HV port. Similar to the LV side, the OVP threshold is the value at which the converter will trigger an error if the measured voltage goes higher. Vstart is the voltage value at which you want the DCDC to start the conversion. In this example, we want the converter to start when the voltage goes over 400 volts and stops when it goes below 300 volts. The bitrate parameter lets you adjust the CAN communication speed. You can choose any value from 1 megabit per second down to 125 kilobits per second. You can also select the application CAN address. It can be set anywhere between 0x100 and 0x780. Next, you can adjust the message sending period as well as the status message period. The default and also the minimum is 10 milliseconds. You can also manage CAN error detection. If you disable it, the converter will not trigger a CAN error when it does not receive messages. The DCDC won't wait for any message, but will execute a message if you send one. You may also choose to adjust the CAN timeout period instead. The sleep mode can be disabled if you do not want the DCDC to enter sleep. You can also change how quickly or slowly it goes into sleep mode. Shutdown timing can be adjusted as well, but the minimum allowed value is 25 milliseconds. Finally, you can set the bootloader CAN address. It must also be between 0x100 and 0x780, but it must not be the same as the application address. In the mode section, you can allow the LV to HV mode, also known as the region mode. The settings here are similar to what you have on the LV side. Vmax is the maximum voltage allowed in the setpoint message range. Vdefault is the initial value set at the beginning of the conversion, and Vmin is the minimum voltage allowed in the setpoint message range. The logic is the same for the overload threshold and I limit. Important point here, in LV to HV mode, the current needs to be negative. In the mode section, you can also allow the converter to operate in the LV to LV mode, also known as the umbilical mode, and allow it to operate in the discharge mode. This will have an impact on the section of settings next to it. Make sure to enter the correct settings in case any of these modes is activated. In the default operation section below, you can also allow the converter to work in canless mode. The converter won't accept any message from your ECU. The DCDC will, however, keep sending you messages and information. You can choose to start the converter by default in HV to LV mode, LV to HV mode, or LV to LV mode. If you select HV to LV mode, you first need to choose which LV port you want to supply. You can select one port or both. If you select LV to HV mode, you need to choose which LV port will act as the source. And if you select LV to LV mode, you need to choose which LV port will be used as the output of the conversion. In the Advanced Settings tab, you can adjust the allowed reverse current and link the LV ports. You can set the reverse current up to 75%. This defines the maximum reverse current the converter will accept. The I limit positive setting applies to HV to LV conversion. It allows a certain level of reverse current during this operation. The I limit negative setting applies when operating in LV to HV mode or LV to LV mode. If you are using multiple LV ports and want to physically link them together, you must also link them in the software. Once done, go back to the Settings tab. You will see that the LV ports are now tied together. For more information, please refer to the user manual provided. The user manual, along with all necessary documents and files, can be found either on the USB drive included with the unit or on our online portal. If you are unsure about any of these settings, don't hesitate to contact us. Once all settings have been configured, the final step is to flash them onto the converter by selecting Flash in the menu bar. If the flash is successful, you'll see your parameters displayed on the main page. Finally, click on the Start Application to leave the bootloader mode. You are now ready to start power conversion. For more details on this critical step, please check the video linked here.